All right, these are the solutions to what was a very tricky linear functions test. All right, so the first two questions there involved some simplifying. So what we're going to do here with this one is use the distributive law. So this will be negative 8a. Negative times a negative is a positive. 4 3s are 12. And there was your 1 mark. For this one here, a lot of you guys just cancelled the 5s out and let it be 1 or 15y plus 1. But remember, what you want to do is attempt to take out a common factor off the numerator. So we're going to rewrite this as 5, 3y plus 1 over 5. And note, you've got the product of terms here in the numerator. That means now you can cancel off the 5s. That means the answer is 3y plus 1. Okay, this one here was a bit of a mess, and it's a tricky one here because of this negative. So there's a couple of ways of doing this problem here, but what I'm going to do is find a common denominator here, and I'll take it 21 as a common denominator. So that means that this was multiplied by 7, so I'm going to do 7, 4, take 2x. And this one here was multiplied by 3, so it's 3 by 4x plus 5. All right, so what we're going to do is expand it and write it as one big fraction. Okay, so it's all over 21. And it's 7, 4, take, I'm just going to rewrite it as one big fraction, take 3, 4x plus 5. All right, so now I'm going to use the distributive law. So it's 28 take away 14x, take away 12, take away 15, all over 21, all of it. And then what we're going to do is collect up the like terms. So that is 13, 12x, I've forgotten the x there. So here we've got 13 take away 26x over 21. So what a lot of you guys did was multiply by 21 at some point to, in inverted commas, get rid of the denominator. But remember, with an expression like this, you just can't get rid of things. Okay, so that was a move that you couldn't make on that one. So I think it was 1 mark for the denominator or the common denominator, and then another mark here for the correct fraction at the end. Right, so this one here is a solve. So what we're going to do is collect up the x's. That means we've got to get them out of the brackets. That means we need to use the distributive law. So 4x take 4 plus 7x plus 14 equals 8. That is 11x take plus 10 rather equals 8. Right, so what I've done is I've collected up the like terms there. Now what we're going to do is say this is 11x, so I'm going to take 10 and take 10 is negative 2, divide by 11, divide by 11, x is negative 2 on 11. Right, this was a bit of a mess, this one as well. So many of you decide to multiply both sides by 3 or subtract 3 from both sides. So subtracting 3 would be the better move to start this one off. Negative x on 2 equals negative 1. Then what you need to do is multiply both sides by 2. So negative x equals negative 2. And then what we're going to do is divide this side by negative 1 and divide this side by negative 1, x equals 2. Okay, solutions to the pair of simultaneous equations. Note that there's 2 variables here, so we need to give 2 solutions, a solution for x and a solution for y. So what I'm going to do here is just check how I can eliminate one of the variables. So the y is primed for elimination, and the way I'm going to eliminate is by doing subtraction. Okay, so subtraction, this is 1, this is 2, and I'm going to do 1, take away 2. Okay, that means I've got x subtract 3x, which is negative 2x. Negative y subtract negative y, which means negative y plus y, which cancels those out. And 12 take away 4 is equal to 8. divide by -2, divide by -2, x equals -4. Right, many of you stopped at this point, and so just remember that simultaneous equations have two solutions, okay, or a coordinate set, an x value and a y value. So what we're going to do is sub x equals -4 into one of the equations, and I'm going to put it back into the simplest one, which is 1. So it's -4 take y equals 12, negative y equals 16, y equals -16. So there's my solution there, x equals -4 and y equals -16. Right, here's the incomplete table of values for this. Okay, so what we need to do is fill in the shaded cells, and we can use the working out in the space below. All right, so the first thing is that this is a relationship between y and x, and they've given us a value of x, and they want to know what y is. So what we're going to do is put this value of x into this equation to find out what y is. So y equals 3 times 2 over 2 plus 4, y equals 6 over 2 plus 4, y equals 3 plus 4, y equals 7. So in this box, it was a 7. This one here says, what's the value of x when y is 9 on 2? So what we're going to do is sub 9 on 2 on equals 3x over 2 plus 4. All right, so a method to solve this one here is to multiply both sides by 2 to get x by itself. I'm going to times this by 2, and it's really important to note that you're timesing the 4 by 2 and this one by 2 as well. So when you times both sides, it's all the terms on the sides. All right, so 9 on 2 times 2 is just 9. 3x on 2 times 2 is just 3x, and 4 times 2 is 8. All right, now what we're going to do is subtract 8 from both sides, leaving me with 1 and 3x. Divide by 3, divide by 3. 1/3 is equal to x, or x is 1/3. So in that box should be 1/3. All right, so this is our first show that question, and what we're going to do is use some mathematics to show that the midpoint between these two lines, or these two coordinates rather, is this coordinate pair. Okay, so we're just going to note that the midpoint formula is x1 plus x2 over 2, the average of the x values, y1 plus y2 over 2, average of the y values. So what we're going to do is add together the x values, which is 1 and 0, and add together the y values, which is 10 plus 6 over 2. So we get 1 over 2, comma, 16 over 2, and 8 as required. All right, the y-intercept of a line connecting A and B. So there was two ways of doing this, and many of you went in and said, all right, I'm going to calculate the gradient. M equals y2 take y1, x2 take x1. Calculated the gradient, sub that into y equals mx plus c. So you sub that in, chose one of the points from here to find out what the y-intercept was. And that was a really long approach, and really that's not what we're after for a 1-mark question. All we wanted you to do is have a look at the coordinates you were given, and this one here is 0, 6, and that is that the y-intercept occurs when x is equal to 0. So actually we can just state 0, 6 is the y-intercept. So the distance from A to B, okay, so the distance formula which was on your sheet is distance equals the square root of x1 take x2 plus y1 take y2. All right, so the coordinates were the x values, which was 1 squared, and the y values, which we're just going to do 10 take away 6 or 6 take away 10. Either it doesn't matter because, and I forgot to put that in the formula there, both of those are squared, which means even if it's a negative value, squaring it makes it positive. So I'm just going to look at the difference between these, which is 4, and note that it's 4 squared. So that's going to be equal to the square root of 1 plus 16. And that is the square root of 17. All right, so this one here, C is another point on the same line as A and B, where you'll recall A was 0, 6, B was 1 and, forgotten, 1 and 10, I think it was. 1 and 10. So that's that coordinate point there. That's our line. There is A, there is B. So C is another point on this line somewhere. The distance from B to C, that is the distance from B to wherever C is equal to the distance from A to B. So it's the same distance. So what is a possible coordinate point of C? So if the distance, so what we just want to do is jump the same distance to end up at a point here, which means as x increases by 1, the y values are going up, or as x increases by 1, the y values go up by 4, 1, 4. So it could be 2 and 14 would be the same distance. So that distance there now would be the same distance as that there. Excuse me. All right, so a line has the equation here. Ms. Mount believes that it's 3 and, well, this is the perpendicular line, and Ms. Lowinger believes that it is 1/3. So we're going to justify that Ms. Lowinger is correct. So there's a few ways of doing this, but noting that for perpendicular lines, that m1 times m2 must be equal to -1. All right, so let's put in Ms. Lowinger's two gradients then. So the original gradient m1 was -3. She's proposing that the gradient of a line running perpendicular is 1/3 equals -1. Let's just test whether this is the case. That's -3 over 3 equals -1. -1 equals -1. Therefore, she is correct. And that's all you needed to do. A lot of you wrote a long sentence there, but justifying means that mathematics is just fine to justify that. So a line that is perpendicular to this line here goes through this point here, 2, 5. So state the equation of this line. So we already know what the gradient is going to be. It's going to be 1/3. So the equation is going to take this form, y equals 1/3 x plus c, and we know that it goes through this point here. So we're going to sub 5 equals 1/3 times 2 plus c. 5 equals 2/3 plus c. So c is going to equal, I'm going to subtract 2/3 from this side and subtract 2/3 from this side. C is equal to 5, take away 2/3. C is equal to 15/3. So I'm just finding a common denominator here. That's 5 over 1. Take away 2/3. C is equal to 13/3. So I know my final equation is, therefore, y equals 1/3 x plus 13/3. So a couple of graphs here. So for this one here, we want to make sure that we label the coordinates of intercepts and endpoints where it's appropriate. So this won't have any endpoints because it hasn't got a restricted domain. So in this form here, it's quite easy to get the x-intercept and the y-intercept. So x-int when y is equal to 0. So let's sub y equals 0. That's going to give us 2x equals 6. Divide by 2, divide by 2, x equals 3. So plot that point. Okay, the y-intercept when x is equal to 0. So that's going to give us -3y equals 6. Divide by -3, divide by -3. Y equals -2. So down there. So it goes through that point and that point. So we're going to label them as coordinates. So that's when x is 0, y is -2, 3, 0 there. And our line must be drawn with a ruler. Needs to go through those points there. All right, this one here, we're going to note that, first of all, that y equals 4x plus 0 means that because our c value here is 0, that it certainly goes through the origin, 0, 0. So then what we're going to do is just work out what the value is at the start point of the equation. Okay, so it's x equals -1. So y equals 4 times -1, y equals -4. That is when x is -1, y is -4. So that's that coordinate point there. Now note that we're not going to accept that value. It's got to be more than it. So that has to be an open circle. And from there, it's going to run through the origin and continue indefinitely for the positive values of x. Okay, so we're just going to label that coordinate, -1, -4. Okay, so this was a bit of a tricky one here. State the value of a that makes the following equation true. That is, this left-hand side has to equal 1. So seeing the divide by a fraction here, what I'm going to do is just note that dividing by a fraction is the same as multiplying by its reciprocal. I'm going to say a, x take 1 on 5 times 20, 2x take 2 equals 1. A, x take 1 on 5 times, I'm just going to note here that this can be factorized. So it's 20 over 2, x take 1 equals 1. Now we're going to note that these two can cancel out. This can cancel with that. That can cancel with that. That should be a 1. That's a 2. So we're left with 2a over 1 equals 1. Divide by 2, divide by 2, a equals a half. Okay, so onto the multiple choice, and we can use our calculator for this. It's not a must, you don't have to. So look at question 1 here, a vertical line. So a vertical line would be something like that. So any vertical line has the equation x equals, and so the only solution to this is this one here, x equals 3. All the rest of them can't be right because they're not in the right form. So don't need an equation for this one, a calculator for this one. We just need to know what the line looks like. Okay, so this one here has a graph, okay, and we know that it's got a gradient of -2 and crosses the x-axis at the point P0. Okay, so what's the equation of the line? The equation of the line is going to be -2x, and the y-intercept is at 7, so -2x plus 7. So this is the x-intercept, which occurs when y is equal to 0. -7, I'm going to subtract 7 from both sides. -2x, x equals +7 on 2, or -7 over -2, x equals 7 on 2. When I divide a negative by a negative, I get a positive. So there's my answer. Okay, this inequality here is the values of x greater than and equal to 3. That's 3 there. So I just need to find the one that will do that, and this is the one here. So -2x less than -6, I divide by -2, divide by -2. Recall that when I divide by a negative number, I must flip the inequality. X is greater than 3, so that's our winner. A line that's parallel to this line could be, okay, so what we're looking for is a line that has a negative gradient, okay, so -3 in this case. Now, this was our winner here. Now, y, let's have a look. So 2y equals -6x plus 2c. That is, I subtracted 6x from this side and 6x from this side. Now I'm going to divide by 2, and divide by 2. Y equals -3x plus c. And it says here c can't be equal to 5, so that is c can take on any other value other than 5. If it was 5 exactly, then it wouldn't be parallel, it would be the same. Okay, so that is our solution there. This one here was a common distractor. This rewritten is y equals negative 3x plus 5, which is exactly the same, not parallel, exactly the same. And this one here, got a bookstore having a sale. Each paperback cost $8 and hardbacks cost 14. Bought 12 books in total. So what we can do here is say X is the number of paperbacks, Y is the number of hardbacks. We're just going to say X plus Y equals 8. Now I know that the cost of them is for the paperback, for the hardback, and Ms. Downey spent $126. I'm looking for the match, and there it is there. This one was a tricky one. So if we quickly draw it, 2, 1 is there. Let's go 7 and 2 is there. And roughly in the middle, 4 and 7, somewhere up there. That's our triangle. So this is A, this one was B, and this one was C. They've given us the equation of the line AB and the equation of the line segment representing the perpendicular height of the triangle is. So the perpendicular height will be this line here, the line running perpendicular to line AB. If this is the equation of the line segment, then what I know is if M1 is equal to 1/5, M2, the equation of the line running perpendicular to this line here, must be the negative reciprocal of this. So it's got to be -5. So that's out and that's out. Now what I need is the y-intercept, and if you actually have a look at the Cartesian plane and see where this line would extend to, it's going to go somewhere up there, which can only really be this one here. Let's just test it out. This line here has got a gradient of -5 and goes through a coordinate for the y-intercept, but it also goes through this point C here. So we're going to sub that in. 7 equals -5 times 4 plus C. 7 equals -20 plus C plus 20 plus 20. C equals 27. There it is, right there. Okay, on to the application questions. So we got Mr. Oski burning some candles, and what he does is tries them out, and they adhere to this sort of situation here. So how long will the candle burn for? So that's up to here, that's 12 mins. Find the gradient of the line pictured will be a simple case of doing M equals Y2. Okay, so we're going to do 8 take away 20 over 8 take away 2. -14 over, no, that's not right. -12 rather, over 6 equals -2. So the gradient, it needed to state a relationship between the variables, so something like as time increases by 1 minute, the height of the candle by 2 centimeters. So state the equation. It's going to be y equals -2 x plus c, or height equals -2t plus c. So I don't know what the y-intercept is, and if I look here, I can't read it off the graph either, but I've got 2 coordinate points. So I'm just going to put 1 into the equation. 8 equals -2 times 8 plus c. 8 equals -16 plus c. Add 16, add 16, c equals 24. Thus the equation is height equals -2t plus 24. Okay, gust of wind blows the candle out when it's 11 centimeters high. So that's going to be, the height is 11 on 2 equals negative 2t plus 24. Not 11 on 2, just 11. Subtract 24, subtract 24, negative 2t equals negative 13. Divide by negative 2, divide by negative 2, t equals, negative divided by negative is a positive, 6.5. Okay, so that means 6.5 minutes. So 6 mins, therefore 6 mins and 30 seconds. So Mr. Denver explains to Miss Oski that due to new school regulations, no candles are to be burned in the gym. So we've got these electronic ones. Actually, this did come true the other day. I can't believe that. The height of the candle was graphed against time. What would be the gradient? So what happens is an electronic candle, as you saw at the mass the other day, gets lit, okay, and will stay at exactly the same height. That is, the height does not change, okay. Time still changes though, okay. So if we were to graph the height of it, if you wanted to imagine it, we've got time versus height, and the height will always be the same. Therefore, the gradient of the line m must be 0. As x increases, or as time increases, the height does not change. Okay, so Ms. Downey went to her hometown of Burnie over the holidays. While in Burnie, she rode to Devonport. And what they did was her sister at the same time was in Devonport, rode her bike to Burnie. So constant bike ride, and the graph that matches the scenario is this. We've also been given the two equations. So this one here is obviously Ms. Downey because y-intercept of 0. Okay, so that means she started in Burnie to Devonport. Okay, and this is her sister with a negative gradient starting at positive 40 and cruising into Burnie. So what's the distance from Burnie to Devonport? Many of you actually use the distance formula here, but really you just had to read it off the graph. This is Burnie here, and this is Devonport here. They are 40 k's apart. After 3/4 of an hour, how far is Ms. Downey from Devonport? Okay, so Ms. Downey, here, we're just going to put that into this. So first calculator use I'll do here, 20 times 0.75 is 15. Now it's important with an application question, girls, to still write that down. So we're doing 20 times 0.75 equals 15. Okay, so therefore 15 kilometers from, in this case, Burnie. But the question says, how far is she from Devonport? So she's 15 kilometers from Burnie, or traveled 15 kilometers from Burnie in that time. And we know that the total distance from Burnie to Devonport is 40. So one more calculation needs to be done here. What we're going to do is say 40 take away 15 equals 25. Therefore, she is 25 kilometers from Devonport. So most of you guys, if you did that question, wrote 15 as your answer there. So make sure you carefully read the question on that one. All right, so what they're going to do is when they pass each other, they're going to perform a high five. Okay, so the high five will occur actually right at this point here. This is when the distance between them is 0. That is, they're in the same spot. So to do that, what we're going to do is simply use the simultaneous equations template. So I'm going to put in my first equation, which is y equals 20x, and the second one, which is y equals negative 22x plus 40, solving for x and y, or h and t, or d and t. Okay, so it's going to occur for a value of x, which is there. Going down of 20 on 21. Okay, so to to write out our working for this one, it's a simple case of going 20x equals negative 22x plus 40, or I shouldn't put x's in here actually, girls. I should put the correct variables, which is t. So 20t equals negative 22t plus 40. T is equal to 20 over 21. Now the question says answer to the nearest minute. So what we're going to do is, that's not a full hour, that's 20 over 21, and if we want to imagine what that is, that's that much of an hour. So we're going to multiply that by 60. That is 57.1 rounded to the nearest minute. We're going to say therefore, or let's do some working out. So it's 20 over 21 multiplied by 60 equals 57.142 ... Therefore, 57 mins to the nearest minute. So they love to talk while they're writing, and Tassie's got some poor mobile coverage. So what they do is they purchase radio transmitters, and that'll allow them to talk when they're 8Ks apart. So at what time, while Ms. Downey and her sister, at what time are they writing when they're first within range to speak to each other using these transmitters? Answer to the nearest minute. So what we're going to do here is actually work out when they're 8Ks apart. Okay, so, and that the first time that occurs is, I don't know, somewhere around here where the distance between these two lines is 8Ks. That is, I want to know when this line here subtract this line here is equal to 8. So what we're going to do is take Ms. Downey's sister's equation, remove Ms. Downey's equation, and let it be equal to 8. It's very similar to solving simultaneous equations, except when we did that, we wanted the difference to be 0. That is, they were equal to each other. So what we're going to say here is negative 22 plus negative 22t plus 40, subtract, so this is Ms. Downey's sister, subtract 20t. I want to know when this removing this is equal to 8. So I'm going to go over to the calc and solve it. And let's get an exact value to begin with. So t in this case, oops, what's going on here? So forget that just for the moment. So t is equal to 16 over 21. Now, because it's answer to the nearest minute, we're going to say then that 16 over 21 times 60 which to the nearest minute is 45 minutes, and this bit here, so we're going to say 45.714 ... Therefore 46 mins.